Computer memory stores information, such as data and programs for immediate use in the computer. The term memory is often synonymous with the term primary storage or main memory. An archaic synonym for memory is store. Computer memory operates at a high speed compared to storage, which is slower but less expensive and higher in capacity. Besides storing opened programs, computer memory serves as disk cache and write buffer to improve both reading and writing performance. Operating systems borrow RAM capacity for caching so long as not needed by running software. If needed, contents of the computer memory can be transferred to storage. A common way of doing this is through a memory management technique called virtual memory. Modern computer memory is implemented as semiconductor memory 5/6, where data is stored within memory cells built from most transistors and other components on an integrated circuit. There are two main kinds of semiconductor memory, volatile and non-volatile. Examples of non-volatile memory are flash memory and ROM, PROM, EPROM, and EPROM memory. Examples of volatile memory are dynamic random access memory, DRAM, used for primary storage, and static random access memory, SRAM, used for CPU cache. Most semiconductor memory is organized into memory cells, each storing one bit, 0 or 1. Flash memory organization includes both 1 bit per memory cell and multi-level cell capable of storing multiple bits per cell. The memory cells are grouped into words of fixed word length, for example, 1, 2, 4, 8, 16, 32, 64 or 128 bits. Each word can be accessed by a binary address of n bits, making it possible to store 2 n words in the memory. A computer memory is just like a human brain. It is used to store data and instructions. Computer memory is the storage space in the computer, where data is to be processed and instructions required for processing are stored. The memory is divided into large number of small parts called cells. Each location or cell has a unique address, which varies from 0 to memory size -1. For example, if the computer has 64K words, then this memory unit has 64*1024 equals 65,536 memory locations. The address of these locations varies from 0 to 65,535. Memory is primarily of three types. Cache memory, primary memory / main memory, secondary memory. Cache memory. Cache memory is a very high-speed semiconductor memory which can speed up the CPU. It acts as a buffer between the CPU and the main memory. It is used to hold those parts of data and program which are most frequently used by the CPU. The parts of data and programs are transferred from the disk to cache memory by the operating system, from where the CPU can access them. The advantages of cache memory are as follows. Cache memory is faster than main memory. It consumes less access time as compared to main memory. It stores the program that can be executed within a short period of time. It stores data for temporary use. The disadvantages of cache memory are as follows. Cache memory has limited capacity. It is very expensive. Primary memory holds only those data and instructions on which the computer is currently working. It has a limited capacity and data is lost when power is switched off. It is generally made up of semiconductor device. These memories are not as fast as registers. The data and instruction required to be processed resides in the main memory. It is divided into two subcategories, RAM and ROM. Characteristics of main memory. These are semiconductor memories. It is known as the main memory. Usually volatile memory. Data is lost in case power is switched off. It is the working memory of the computer. Faster than secondary memories. A computer cannot run without the primary memory. Secondary memory. This type of memory is also known as external memory or non-volatile. It is slower than the main memory. These are used for storing data / information permanently. CPU directly does not access these memories, instead they are accessed via input-output routines. The contents of secondary memories are first transferred to the main memory, and then the CPU can access it. For example, disk, CD-ROM, DVD, etc. Characteristics of secondary memory. These are magnetic and optical memories. It is known as the backup memory. It is a non-volatile memory. Data is permanently stored even if power is switched off. It is used for storage of data in a computer. Computer may run without the secondary memory. Slower than primary memories. RAM, random access memory, is the internal memory of the CPU for storing data, program, and program result. It is a read/write memory which stores data until the machine is working. As soon as the machine is switched off, data is erased. Access time in RAM is independent of the address, that is, each storage location inside the memory is as easy to reach as other locations and takes the same amount of time. Data in the RAM can be accessed randomly, but it is very expensive. RAM is volatile, i.e. data stored in it is lost when we switch off the computer or if there is a power failure. Hence, a backup uninterruptible power system, UPS, is often used with computers. RAM is small, both in terms of its physical size and in the amount of data it can hold. RAM is of two types. Static RAM, SRAM. Dynamic RAM, DRAM. Static RAM, SRAM. The word static indicates that the memory retains its contents as long as power is being supplied. However, data is lost when the power gets down due to volatile nature. SRAM chips use a matrix of 6 transistors and no capacitors. Transistors do not require power to prevent leakage, so SRAM need not be refreshed on a regular basis. There is extra space in the matrix, hence SRAM uses more chips than DRAM for the same amount of storage space, making the manufacturing costs higher. SRAM is thus used as cache memory and has very fast access. Characteristic of static RAM. Long life. No need to refresh. Faster. Used as cache memory. Large size. Expensive. High power consumption. Dynamic RAM, DRAM. DRAM, unlike SRAM, must be continually refreshed in order to maintain the data. This is done by placing the memory on a refresh circuit that rewrites the data several hundred times per second. DRAM is used for most system memory as it is cheap and small. All DRAMs are made up of memory cells, which are composed of one capacitor and one transistor. Characteristics of dynamic RAM. Short data lifetime. Needs to be refreshed continuously. Slower as compared to SRAM. Used as RAM. Smaller in size. Less expensive. Less power consumption. ROM stands for read-only memory. The memory from which we can only read but cannot write on it. This type of memory is non-volatile. The information is stored permanently in such memories during manufacture. A ROM stores such instructions that are required to start a computer. This operation is referred to as bootstrap. ROM chips are not only used in the computer but also in other electronic items like washing machine and microwave oven. Let us now discuss the various types of ROMs and their characteristics. MROM, masked ROM. The very first ROMs were hardwired devices that contained a pre-programmed set of data or instructions. These kind of ROMs are known as masked ROMs, which are inexpensive. PROM, programmable read-only memory. PROM is read-only memory that can be modified only once by a user. The user buys a blank PROM and enters the desired contents using a PROM program. Inside the PROM chip, there are small fuses which are burned open during programming. It can be programmed only once and is not erasable. EPROM, erasable and programmable read-only memory. EPROM can be erased by exposing it to ultraviolet light for a duration of up to 40 minutes. Usually, an EPROM eraser achieves this function. During programming, an electrical charge is trapped in an insulated gate region. The charge is retained for more than 10 years because the charge has no leakage path. For erasing this charge, Ultraviolet light is passed through a quartz crystal window, lid. This exposure to ultraviolet light dissipates the charge. During normal use, the quartz lid is sealed with a sticker. EEPROM, electrically erasable and programmable read-only memory. EEPROM is programmed and erased electrically. It can be erased and reprogrammed about 10,000 times. Both erasing and programming take about 4 to 10 milliseconds, millisecond. In EEPROM, any location can be selectively erased and programmed. EEPROMs can be erased 1 byte at a time, rather than erasing the entire chip. Hence, the process of reprogramming is flexible but slow. Advantages of ROM. The advantages of ROM are as follows. Non-volatile in nature. Cannot be accidentally changed. Cheaper than RAMs. Easy to test. More reliable than RAMs. Static and do not require refreshing. Contents are always known and can be verified. The CPU contains a special set of memory cells called registers that can be read and written to much more rapidly than the main memory area. There are typically between 2 and 100 registers depending on the type of CPU. Registers are used for the most frequently needed data items to avoid having to access main memory every time data is needed. As data is constantly being worked on, reducing the need to access main memory, which is often slow compared to the ALU and control units, greatly increases the computer's speed. Computer main memory comes in 2 principal varieties. Random access memory or RAM. Read-only memory or ROM. RAM can be read and written to any time the CPU commands it, but ROM is preloaded with data and software that never changes, therefore the CPU can only read from it. ROM is typically used to store the computer's initial startup instructions. In general, the contents of RAM are erased when the power to the computer is turned off, but ROM retains its data indefinitely. In a PC, the ROM contains a specialized program called the BIOS that orchestrates loading the computer's operating system from the hard disk drive into RAM whenever the computer is turned on or reset. In embedded computers, which frequently do not have disk drives, all of the required software may be stored in ROM. Software stored in ROM is often called firmware, because it is notionally more like hardware than software. Flash memory blurs the distinction between ROM and RAM, as it retains its data when turned off but is also rewritable. It is typically much slower than conventional ROM and RAM however, so its use is restricted to applications where high speed is unnecessary. In more sophisticated computers there may be 1 or more RAM cache memories, which are slower than registers but faster than main memory. Generally computers with this sort of cache are designed to move frequently needed data into the cache automatically, often without the need for any intervention on the programmer's part. Thank you for watching this video.